Hey guys, today we're going to be talking about compounding continuously on our interest. Last week we talked about compounding quarterly, which was 4 times a year, compounding weekly, which is 52 times a year, and we saw that in some of our examples that the more we compounded, the more money we got if we were talking about saving money. So the more you can compound, the better off you are, like I said, if you're saving. So we should be able to compound more and more and more every minute of every day, every second of every day. Wouldn't that be cool? So we developed this new way of calculating interest, and this is whenever it's compounded continuously. Today you're going to watch the video and take notes on compounding continuously. So you'll need a piece of paper and a pencil. You'll also need your calculator. You'll turn in your notes at the end of class, and that will be for a grade. There will also be some practice problems at the end of the video that you'll need to practice and do on your notes as well. Tomorrow you'll do a small group independent practice activity in class, and that will be turned in. On Wednesday, we will be moving on and wrapping everything up. We will be talking more about credit cards, which is the other end of interest, the end you don't want to be on. We'll be talking about that on Wednesday and Thursday, and most likely wrap up next week with a test next week. So if you're behind on anything, you just got back your quiz and it wasn't so hot, you want to get together with people and you want to go ahead and see if you can get some help on that. Again, I'll be back on Wednesday to help you. But go ahead and try to ask your peers first, since they're there with you now. Okay, so this video I will upload to YouTube. You can go to youtube.com/user/Vogel Math. To see this full video again, if you don't get it all in class, or if you have a friend who's out today, you can tell them to go watch this video and they won't have missed anything. Okay, let's get started. Again, like I said, you need pencil and paper. I'll tell you what you need to write down. You won't need to write down everything, but I will tell you when you need to write things, and those things should be on your paper. Okay, so by now we've realized that the more times we compound our interest, the more the balance of the account will be. So the more we can compound, the better off we are if we're saving money. So the table on the screen shows an account with a beginning balance of $1, compounded a different number of times for 1 year at 100% interest. And this is going to help us get to our compounding continuously formula. But let's just take this basic example. It's really easy just to think about. If we just have $1 in an account, and in some crazy world this account gets 100% interest on it, how would the compounding look and how much would we have? Okay, so just think through this crazy example with me for a second. If I have a principal amount of $1, and I compound it only once per year, that means n equals 1 inside of my compounding formula, which, if you recall, was this: p times 1 plus r over n to the nt. So if I compound it once per year, if n is 1, then at the end of the year I'll have $2, obviously. I start off with $1, I get 100% interest, they're going to give me another $1, I'm going to have doubled my money. If I compound monthly and run this formula with principal as $1, the rate is 100%, so 100% will just be 1 as a decimal. 12 times a year, for just 1 year, times 1 year. Then at the end of that year, I'll have $2.61. Now I'll put the decimals here, you'll see why in a second. But I'll have $2.61 in the bank. If I compound that dollar weekly, 52 times a year, then at the end of that 1 year, I'll have $2.69, a little bit more. If I compound daily, about 365 days in a year, then I'll have $2.71, So a little bit more, but not so much more. Now, if I compound hourly, 24 hours in a day, so 24 times 365, 8,760 hours in a year, then I'll have $2.72. So I'll have an extra penny. If I compound every minute of every day in that year, then I'll compound 525,600 times, which will still give me $2.72. But if I look over here, notice that I have more parts of the penny. Now, the bank's not going to pay me anymore. But looking at these numbers, an interesting thing happens. As I compound more and more, as this number of compounding gets higher, then I get more money, but notice that the money's starting to level off. It doesn't feel like I'm ever going to make it past $2.72. And it's this concept that gets us toward a new irrational number. So far, you already know an irrational number, pi. You've been using pi ever since elementary school. But this gets us toward a new number, one you probably haven't heard of before. And it's because you need to know about exponential functions before you can understand what this number means. The number that we're approaching is called e. And it's a cursive e. You can find e on your calculator. Get out your calculator for a moment. It should be a button that says e to the x power, most likely, like this. It's probably above or near a button that says LN on it. It should be around that button. It's probably the second on that button in most calculators. And you'll need to use this button in our calculations later. But if you find that button and press it, you should get e to the first power is approximately 2.71828 . Okay? Which looks a lot like this number. In fact, it is exactly this number, but there's more decimals. Okay? So e never terminates. The decimals never repeat. It is an irrational number. You will see e, the irrational number e, on your ACT test. So if you're still looking to take it anytime soon, they will often ask you which one of these numbers is irrational. And e might be one of the options. E is an irrational number, so they'll ask you about that every now and then. Okay, but back to this. So we approach this number e, and it's this number e that gets us to a new formula for compounding continuously. Our number of times compounded is going to go towards infinity. We're going to compound an infinite number of times per year. So plugging in infinity into our formula really doesn't really help us much. So we need a new formula. Okay. I just said that. Cool. Compounding continuously means the account is constantly adding the interest earned back to the principal amount, then calculating new interest. Okay? So for this reason, there are an infinite number of compoundings performed per year. That's what we just said. And so here's your new formula. And it's a lot easier than the old one. So you need to write this down on your paper. Everything on this slide needs to be written on your paper. And you probably want to put a box around this formula. This formula is for compounding continuously. You may need to pause the video here to get it copied. Okay, moving on. Let's look at an example of how this works. You'll need to copy this example and add all the notes on this slide and the work on this slide onto your paper. Example, determine the balance on an account that is compounded continuously for 3 years with a principal of $2,000 at a rate of 2.5%, which would be awesome if we could have those savings rates right now. But let's look and see what this looks like. A, again, stands for the total amount in the account. P is the principal amount, just like it was last week. E is your new irrational number that you know. It is a button on your calculator. RT stands for what it always has, rate times time. The rate still needs to be written as a decimal, not a percent, and time is in years. So in this problem, if I calculate the amount in the account, I'm going to use P, E to the RT power. Remember that you need to use your order of operations after you plug into this. The principal on the account is $2,000 times E. I'm just going to write E on my paper. I'm going to use it in my calculator in a second. Raised to the power of R times T. 2.5% as a decimal would be 0.025. And time in this problem is 3 years. Now, I will want to go ahead and multiply my exponent together. So 0.025 times 3 should give you 0.075. So 2,000 e to the power of 0.075. Now, when I put this in my calculator, follow the order of operations. I need to evaluate the exponent before I can multiply. So in my calculator, I'm going to find my button E, and I'm going to say E to this power, 0.075, and I get this part right here gives me about 1.077884151. And I'm going to leave that number in my calculator and multiply by $2,000. I'm going to round my answer to the nearest penny. I have $2,155.77. So I'll have $2,155.77 in that account at the end of 3 years. Make sure you have this example and everything that's written on the screen on your paper. Determine the balance on an account that is compounded continuously for 10 years with a principal of $5,000 and a rate of 4%. Copy this problem onto your paper. Okay? So, I'm going to use my compounding continuously formula. It says continuously. The principal on the account is $5,000. The rate is 4%, which is 0.04 as a decimal. And time, let's see, 10 years. So time is 10. So 0.04 times 10 is going to give you an exponent of just 0.4. So now I can evaluate my exponent, and I can multiply by 5 grand. So find the E button on your calculator. Say E to the power of 0.4. Hit the Enter key, and then multiply by $5,000. At the end of 10 years, you should have $7,459.12. Okay. Determine the interest earned on an account that's compounded continuously for 10 years with a principal of $5 grand at a rate of 4%. This is the last problem. So let's just go back. The only difference is I want you to determine the interest. So on your notes, keep going with this problem. And you want to write how much interest was earned. Okay, so just like last week, all you need to do is take your account balance and subtract the principal. The principal was the money you put in the account in the first place. So subtract out the principal, and that will tell you how much interest you earned. So the interest earned is $5,000 less than this, so $2,459.12. So be careful. Sometimes the problems will say how much is the account balance, and sometimes it'll say how much interest you made. Okay, so this is a rather simple formula to use. It's a lot easier than the one we did last week. So let me give you a couple of problems. You try these two problems on your own. Write them on your notes paper. Think about them on your own first. And then after a few minutes, if you can't get it on your own, you can ask somebody in your group to help you. Okay, so here are your two problems. Try them on your own, and then partner up if you need to. You must have the problems written down onto your notes paper and worked out before you leave. Pause the video here, restart the video to see the solutions. Okay, for problem number 1, you're going to use your compounding continuously formula because that's how the problem says the account compounds. P will be 500. The rate as a decimal is 0.005. And for 5 years will be your time. Multiply your exponents together to get 0.025. In your calculator, do e to the 0.025 power times 500. You'll get $512.66. Now notice the problem did say how much interest will she earn. So subtract out the $500 principal, and she earns $12.66 in interest. Okay, here's problem number 2. So in problem number 2, we probably want to calculate the outcome of both options after 3 years. So in option 1, notice that he can invest his money into a savings account that gets 1% interest compounded quarterly. Now because it's compounded quarterly, that's what we did last week. You're going to have to use the compounding in times per year formula to calculate the outcome of option 1. So go back to your formula from last week. He compounds 4 times a year if he does quarterly at 1% interest, so that's 0.01. Running those calculations, he'll have $1,030.42 at the end of 3 years. Option 2 is that he can invest his money into an account that gets 0.75% interest compounded continuously. Now in this option, he gets a less percentage rate per year, but it compounds differently. Since it compounds continuously, I'm going to use the formula for compounding continuously, which has E in it. Substitute in your values. Notice 0.75% is 0.0075 for 3 years. So I'll get $1,022.76. The question is, if you plan to leave it alone for 3 years, don't add to it or take from it, which is the better option and why? So Mark should go with option 1. Option 1 is the best option for Mark because he will have more money at the end of 3 years. Make sure you have all of your example problems and notes copied down as you were instructed to do so in the video. You need to make sure your name is on your paper. You need to turn these in. Tomorrow you will be doing very similar problems. You'll be allowed to use these notes, but you will have to turn them back in as well. You'll be doing these types of problems again. There will be some compounding quarterly, weekly, monthly type problems mixed in with compounding continuously type problems. So make sure you read the problems carefully. If you have any questions, make sure you're asking around to people in your group. Make sure that you are working on this. If you need help with compounding this way, make sure you're getting help with that over the next couple of days.